Hello and welcome to the next installment of the videos for AP Physics B Summer Assignment. Today we're going to be looking at vector operations. What we're going to cover today are the following: adding and subtracting vectors, multiplying a vector by a scalar, and resolving a vector into components. Vectors are quantities with magnitude and direction. Scalars are quantities that have a magnitude but do not have a direction. Now, scalars can be added just like they were numbers. For example, we can add two masses together as if they were just numbers. 5 kilograms plus 5 kilograms, of course, equals 10 kilograms. Easy. However, vectors follow different rules. Well, why is that? Let's say, for example, that I'm traveling 5 meters and then another 4 meters. I could try to calculate my total displacement, which is the difference between my starting and my ending point. Looking at the numbers, I would think that that was 9 meters. Is it? Maybe not. So if I were to travel 5 meters east and then another 4 meters east, then my total displacement, difference from where I started and where I ended, is in fact 9 meters to the east. On the other hand, if I travel 5 meters east, like this, and then 5 meters west, or 4 meters west, like this, well, the difference between where I started and where I ended is not 9 meters, right? It's 1 meter to the east. So we have to be careful when we are adding and subtracting vectors. We have to use different rules. The direction of the vector matters. Whether or not it's pointing east or west actually matters. So a couple of rules to note. The negative form of a vector is going to be the same length as a vector, but pointing in the opposite direction. So, for example, the vector that I have on the board here, if I wanted to draw its negative, all I would do is draw a vector that points exactly in the opposite direction, with the arrow facing the other way, but the same length. Now, it doesn't matter where I draw it, as long as I'm drawing it in the same direction and the same length. Vectors are identical no matter where you put them. You can subtract a vector by just adding its negative. So let's say I wanted to subtract that vector from itself. All I would do is add the negative of the vector to the vector. I'd end up with a result of 0. If you multiply a vector by a scalar, you get another vector, just increased in length by that amount. So for example, if I were to double this vector, I would get a vector that's pointing in the same direction, but twice the length. When we're adding vectors graphically using the rules that I just showed you, there's other rules that you have to follow. What we do is we line the vectors up so that the tip of the first vector lines up with the tail of the second vector. And then the resultant vector, which would be the sum of all of them, will be drawn from the tail of the last vector to the tip of the first. Now, that's a lot of words, it's a lot of information, and it'll make a whole lot more sense when I actually show you what to do. So let's take the cat from the previous example. The cat is going to perform the same 3 actions that he did before. The cat runs 5 meters to the east, then 6 meters to the west, and finally 10 meters at 70 degrees west of north. How are we going to add those as if they were vectors? First thing we need to do is a coordinate system, and again we're going to use the standard coordinate system Cartesian that we've been using with positive x-axis here and the positive y-axis here. And then we're going to start with the first vector, which was 5 meters to the east. So I'm going to say that 1 block is equivalent to 1 meter. That seems convenient, and I'm going to start drawing. Cat runs 5 meters to the east, so we're going to count out 5 blocks eastward. Then the cat goes 6 meters west. So I'm going to go from the tip of the first vector and count backwards. 1, 2, 3, 4, 5, 6. So I end up here. And then starting from my end point, I'm going to draw another vector that is 10 meters west of north at 70 degrees, which would look something like this. And of course, that's an estimate. And then my resultant would be drawn from my starting point, which was right over here, to my ending point. Like that. That's how we add vectors graphically. And then if we wanted to find the actual length of the resultant vector, we would take out a ruler and measure it, and then we would take a protractor and determine the angle from the positive x-axis to the resultant. And that would be our direction. That's how we do this. That's graphical vector addition. The resultant was determined by drawing a straight line from the tail of the first vector to the tip of the third. There are really obvious problems with doing it this way. First of all, it's really difficult to add the vectors precisely. You have to take a ruler and measure very, very accurately in order to get a good answer. Because of this, there's another method for adding vectors, and this is one that we're going to be using most often in this class, and that is addition of vectors algebraically.